We're going to talk about transaction and concurrency control. We use a transaction to guarantee the data integrity when the database data is modified. We use concurrency control to maintain the data consistency and data integrity in a multi-user database environment while multiple users are using the database data simultaneously. A transaction is a logical unit of work. There are four properties of a transaction: A, C, I, D. You can read about the definition for each property here. In a database environment, we use locking and row versioning to maintain the data integrity and data consistency. With locking, we use locks to block other transactions from modifying or accessing resources a transaction is dependent on. With row versioning, we will make a copy of a record or take a snapshot of a record when the record is modified. Generally speaking, locking is used in a database environment in which most activities are writes. Locking can better protect data, but locking will decrease concurrency. In a database environment, if most activities are reads, we tend to use row versioning. Row versioning does not best protect data, but row versioning will increase concurrency. In a multi-user database environment, if we do not control concurrency, there may be some potential problems. Here are some common problems: lost updates, dirty read, non-repeatable read, and phantom reads. You can read about the definition for each problem here. There are two types of concurrency control for a multi-user database environment. In an environment, if most activities are writes, we tend to use the pessimistic concurrency control. We use locks to implement pessimistic concurrency control. In an environment, if most activities are reads, we tend to use the optimistic concurrency control. We use row versions and snapshots to implement optimistic concurrency control. The database engine can implement locking at different levels of granularity. Locking at a smaller granularity, such as rows, will increase concurrency, but it has a higher overhead on maintaining the locks. Locking at a larger granularity, such as tables, will decrease concurrency. It will also minimize the overhead. A group of locks at multiple levels of granularity is commonly called a lock hierarchy. Here are the lock modes for your reference. we have the shared mode, the exclusive mode, among others. The database engine will escalate logs when the overhead is too high. Log escalation is the process of converting many fine-grained logs into fewer coarse-grained logs. This will minimize the overhead, but it will also decrease concurrency. A deadlock is a scenario in which two transactions are each holding resources the other transaction is waiting for. The database engine will choose a transaction to terminate, and the termination of the transaction will break the deadlock. The chosen transaction is commonly called a victim. In a busy production environment, very often the human intervention is required to break a deadlock in time. Here are some techniques we can use to minimize deadlocks. We want all transactions to access resources in the same order. Also, we want to keep a transaction as short as possible. In a large and busy environment, the database engine will implement log partitioning. Log partitioning is to split a single large log resource into multiple smaller log resources. This will avoid a bottleneck. This feature is automatically controlled and managed by the database engine. We can go to this link to learn more about all the topics we just talked about. This is the end of our discussion.